Bonsoir, Wuppertal! Hey everyone! Ladies and gentlemen, visitors, dear teams, I miss you. Seriously, I miss you. It's warm in here, isn't it? Yeah, I know, we already opened the doors, and it's about to get even warmer because tonight we do not have just one award, we do have three of them. We start with the first one, the big one, the Engineering and Construction Award, and then we have two bonus out of competition awards, which is the Indoor Air Quality Award and the Solar Award. This is what we're looking forward to. And of course, announcing the award winners. And in order to get a better understanding what the Engineering and Construction Award is about, please welcome with me the competition director, Professor Carsten Voss. He's the professor for Building Physics and Technical Services. Professor Carsten Voss, welcome.
So, welcome everybody to this award ceremony on engineering and construction. It's one of the 7 contests, and it's one of the 10 contests, one of the 7 juried contests. And it's one of the contests being part of Solar Decathlon since 20 years, always about engineering and construction. You might have seen changes over time with different profile of the Solar Decathlon, but this was part of it ever. And for a better understanding, I want to cite a few things from our rules. So the students, the decathletes, should know it, but maybe others not. Teams, the objectives. Teams will demonstrate and justify the measures undertaken in the path towards climate-neutral buildings. This covers the construction as well as the engineering in interaction with the architecture. And small comment to that, structural engineering in this competition here in Wuppertal is more taken as part of the architecture contest. So this will be awarded next week. There are, of course, clear criteria. The sub-scoring is based on the following factors: the energy concept, the performance analysis undertaken to develop and justify the concept, and the life cycle carbon footprint. And remember, the energy concept and the performance analysis, both topics cover the design challenge as well as the HDU here on the site. The life cycle carbon footprint focuses on the house you set up here on the site. So the evaluation of the energy concept covers all measures undertaken to reduce the energy demand of the building, and this includes the building design, like passive solar, shading, etc. The construction means, for example, insulation, and the selection of appliances and the energy supply system, including its interaction with the grid. So it's a wide field, and to summarize, it's about solar energy engineering as a key issue. In real building practice, this has shifted, I can say, from a luxury point 20 years or 30 years ago to a must in all types of buildings now. And this is fantastic. This is a fantastic story which has to do with price reduction, which has to do with innovation, and lots of work you have done in the past. And all of this is also only valid when you don't waste solar energy, because that doesn't pay. So it's always on efficiency and finding the right balance between efficiency measures and renewable energy supply. That's the background for this contest, and I give back to Wilma to announce our speakers for the lectures. Thank you.
Our first lecturer for tonight is the owner of the Institute for Building Energy Research, which he founded himself in 2021. For Luxembourg, he has accompanied the implementation of the EPBD, which is the Energy Performance of Buildings Directive. And for Luxembourg, he represents Luxembourg as a national delegate at the Concerted Action. Please welcome with me Dr. Markus Lichtmes.
Good evening, everyone. First of all, it's a great pleasure for me to be here, to be part of the Solar Decathlon as a jury member. And I really liked this great journey the last few days, see all these gorgeous projects you have made. And now, of course, it's time for a little lecture. And I will talk about strategies or ways to improve the energy performance of buildings. To design a building or to develop an energy concept, there are always different aspects taken into account: social aspects, health aspect, the building by itself, and also ecologic aspects. And we can count many more of that. But what you did in your project is architects and engineers worked together over 3 years or 2 years, how long it takes, and developed great concepts and great buildings. And hopefully this stay the same in the future for you. Developing an energy efficient building, you can roughly divide in 4 steps. The first step is to reduce the energy demand of a building. That means energy first, or the principal energy first. Every single kilowatt hour, what you don't need, you don't have to produce, even if it's come from renewable sources. And if you optimized the building in that way, you come to step 2, and this is the implementation of renewable energy. You have to check the surroundings of the building, the possibility of energy sources you can use for deliver energy in the building. And the third step is kind of new, because their electrical energy production becomes more important, and there's a lot of saving potential to harmonize the energy production with the energy demand. To switch on appliance when the sun is shining, and to store energy during the day that you can use it in the night. There was also part of many teams or many concepts in the teams. And then if you are on the last step, I would say the rest energy demand what the building needs, you have to produce as much efficient as you can. And then I checked all the projects and they're developing in the process, and I've seen that most of the teams does it well. I mean, they analyzed the shading system, they analyzed the surroundings, they checked everything and developed energy concepts based on the principle I told before. And then I asked myself, why I should give a lecture about that when you already know it? Then I decide shortly to switch the topic. The new topic is environmental assessment of building materials and components. As you know, you had to work on carbon dioxide footprint of the building, to count all the materials, to count the global warming effect, what the building causes by using it and by creating it. But life cycle assessment, is it real, focused on CO2 emissions only? That is a question we could ask us. Usually the key indicator which are used for such things is CO2 emissions. But there are other environmental impacts, and those are often not discussed. For example, if you have a renewable material, the advantage of it is it bounds CO2. A sustainable farming is of course required, that you can reuse the material. And if you focus on CO2 emissions, as more wood you use, as better the CO2 rating is, because it's bound in it. And on the other hand, or on the other side, wood or renewable materials are also limited resources, and we have to take care that we don't overuse it. And based on CO2 emissions, you get normally no reward to design clever and intelligent, slim building structures using less wood, but using the right materials. And some of your teams mentioned that. Another example is for renewable material cotton. For example, when cotton is relatively harmful to the environment, it consumes a lot of water, a lot of pesticides are used to grow it, and the farming spots on the world, usually India and China. So that's probably not the best conditions to farm that material. And in the process you worked for the carbon footprint of the building, you have to check environmental product declarations. That is, it's called EPD, that contains environmental indicators. And so there is not so nice part of the moment, but you have to have a little bit fantasy, because this is cover from the Time magazine, but because of the rule of the rights, I cannot show them, so I hide it a little bit. But what I want to say is, in the past, in the 80s, some of you probably could know it, but the most, probably not. The acid rain situation was a great discussion to avoid that. And after that, in the 90s, the ozone hole was a big topic. And it's also an indicator in an EPD. But now we are dealing with global warming, and of course this is a major problem we have to deal with. But we should not focus only on that. When you follow a more holistic approach, you can take all data from an EPD into account. There is a standard, 15804. It's reinvented last year. It contains 10 major indicators, from global warming, ozone topics, acidification, eutrophication, and the use of fossils and the use of non-fossil resources like rare earth and minerals. And as well, the water dilapation. The question is how we can combine all these factors into a figure we can use to rate the building or material. This is a life cycle. I think everyone knows how does it work. It goes from the production of a product in the building process, then it has a usage time, and by the end of the building we dispose it or probably reuse it. But if you see this translated in an EPD, you get a sheet like this. And that counts a lot of figures, and it's hard to rank the numbers, the values. And it's also hard to compare one product to another one. And we need to have a more easy to understand way to deal with those figures. I give you an example. We just take the values from the production of a product. What you can see is in the second column, different units. And then you have figures, but you cannot count different units together because it's not possible. We have to deal with that. To sum up all the values, there's one possibility, normalizing these units and to rate the impact, which impact category matters most. Therefore, is a rating system necessary. I will explain it a little bit later. What normalization means? Normalization means that you count all the CO2 emissions, of course equivalents from the total global, and count them together. That leads to an emission of 8,100 kilogram CO2 per annum per person, and that's, let's say, at the inventory of our planet, and you have to do that for all the category. There is some research from the Joint Research Center and from the European Commission. They count this inventory for our planet since a couple of years. And then you take then you take the data sheet from an EPD, and you know how much emissions the production of that materials emits. And then easily you make a ratio, you take the CO2 emissions from your product and divide it by the total global emissions, and what you get is a relative amount of that product you use from the whole CO2 emissions on the world. That's a relative value, and so the units are gone. Then comes the tricky part to say what inference parameter matters most, and there's also a huge study made from the research center from the European Commission that tried to figure out a way to weight the different aspects from the environmental pollution, to weight them into categories. I will not go into detail for that, but just this is the ratio, and what you can see is this is a pie chart, and the climate change has approximately 30% weight, but all the other aspects are also taken into account. So now we have the units are gone, then we have a rating system, we know what impact categories matters most on our planet, then we get a number. The number is, in that case, 11.9. You see a little pie chart on the left-hand side. This shows you how's the composition of the indicator. So, what does this number tell you? That's just a value, and you have to compare this value to another one. For that, you can use a reference part, a reference value. You fix one insulation, or one material, or one construction type, and say this is the reference value which most of the buildings are constructed with. And then you can compare the material you use to that value, and you come up with a traffic light system. And if the materials counts worse, you stop using that product. If it's something in the reference value, start thinking about it, change it. And if it's dark blue, that was a good pick, use it. Here you can see, it's not to see in detail, but that's a ranking of the criteria for different insulation materials. That just gives you an overview how the system can work. And as I mentioned before at the beginning, there was the cotton that's on the top. You see that's one of the worst insulation in that combination. But when you use the cotton made from ecological growing, it's much better. And if you only count the CO2 emissions, the conventional produced cotton will be better. And we have to avoid that. We have to take everything into account. This indicator can be used for materials, but also for constructions, and for buildings and technical systems. Yeah, I think many of you already know that I'm like to produce teaching tools, so you have to use SimRoom for your competition. And there's a new tool, it's called SpiderCalc. Thanks, Helmut. He invented this name yesterday. And it's about one tool that combines everything together. Comfort aspects, energy aspects, technical system, and as well the environmental footprint. And in this tool there are about 600 EPDs included. And it's possible to calculate the energy demand on every area of your planet. There is more than 1,000 locations included, and you can directly check what happens when I move the building from Wuppertal to Taiwan, what's the impact of the environment. As always, that's kind of a hobby of mine, and this tool is for free for all the students who like to learn a little bit more about sustainable buildings and energy design. So this was my short lecture. Sorry for that it was a little bit technical, and thank you.
Thank you, Markus. Our second lecturer is an associate professor at the Division of Energy and Building Design at the Lund University in Sweden. She perfectly combines architecture and engineering because she does have an MSc in architecture and a PhD in engineering, plus 35 years, more than 35 years of experience with energy efficient buildings, combining the whole building approach, which makes her a perfect pick for the jury. Plus, she's presently leading the international research project on solar neighborhood planning. Please welcome with me Professor Maria Wall.
So, thank you for that. I'm also very happy to be here. It has been really a pleasure, and I really enjoyed to be part of this competition as a jury member. And as you could understand, I would like to talk about solar strategies because I like it, and I think it's very important also for Solar Decathlon. So to remind us, we have a lot of solar contributions that we use. And we use passive solar energy, both indoors and outdoors, to reduce the heating demand and improve thermal comfort and health. And we use daylighting, we use it for daylighting buildings and outdoor areas, of course. And this is to reduce electricity for lighting and to improve the visual comfort and health. And we use it for local renewable energy production, using photovoltaics to produce electricity and solar thermal systems to help create energy and resource self-sufficient environments, so that we don't have to rely on energy imports, and we can create resilience to energy price fluctuations, which is very important today, as you know. And we can use it for local food production and for green areas to improve air quality and reducing stormwater. So we can really use it for a lot of things. So it's important that we do it also. And we can, if we look at active and passive solar energy, there are many ways we can integrate it in the built environment, both thermally to produce hot water, but also produce electricity. We can use it, daylighting through windows and so on. So here are only a few examples that I found on my way on different trips. So regarding buildings, why is solar energy important? Well, we are aiming at zero emission buildings or zero energy buildings or similar concepts. And as you heard before, it's important to first reduce the energy demand, and you know that well, and to then increase the use of renewable energy. So if you imagine that we put PV panels and solar thermal on all buildings all around us in the city, this will also, of course, also have a great impact, but it also has some consequences because it influences the building's architecture and the urban landscape. So we really need to plan how we integrate solar strategies into the buildings in a good way. So in this way, we need still development of new solar products that are more architecturally well-fitting to buildings, and they also need to fit to the facade and roof material, or the opposite. We need developments of facade and roof materials so that they kind of, they are look alike, the solar products, so we can integrate it well. And it's important that the manufacturers develop this together. A long time ago, 10 years from now, we finalized an International Energy Agency project within solar heating and cooling program called Solar Energy and Architecture, where we looked at the architectural integration of solar systems. And here are just a few examples of the case studies, and those we selected as good examples, and there are more on the website. So on the left upper, you have an office building in Switzerland. All 3 examples are from Switzerland. And the one on the top right is a residential plus energy house. And on the bottom, you have an industry building. And here you have solar thermal collectors on the facade. And then you also have a kind of dummy elements, and they look exactly like the panels. So you can't see which part that is the active solar panel and which part is just the facade material. And I think that is a good way to develop the architecture. So we have some innovative solar products, but we need more, that's for sure. And I also would like to highlight the perspective of urban planning and urban areas in an historical planning perspective. So for more than 2,000 years, urban density was ruled by access to daylight and natural ventilation. And we had some simple rules during all this time. We had solar access, the ability to have uninterrupted direct rays of sunlight fall onto one's property. And we had the right to light, a legally enforceable right to a reasonable proportion of the natural unobstructed flow of direct solar radiation. But then came electricity, with electric lighting and mechanical ventilation. And those simple rules were kind of forgotten or not needed anymore. So in the second half of the 20th century, and we got the densification of cities when the population was growing also. But now we are aiming at sustainable cities and more renewable energy that push for this right to light again, for daylight and solar energy production. But on the other hand, we have an increased population and environmental gains of walkable and public transport that push towards an increased density. So it is a struggle, and it's not easy to be an urban planner. We can understand that. So, but looking at the neighborhood scale, we have great opportunities here also, not only on the building scale. And it is a means to achieve net zero energy districts and low carbon cities. And if we address both active and passive solar strategies when we plan neighborhoods, it enables us to identify synergies and avoid conflicts between competing users. So, for instance, in the photo you have a struggle here between vegetation and PV. So we shouldn't waste the possibilities to use the available surfaces we have, to think more thoroughly about this. When we do this, it's important to create long-term solar access for energy production and daylighting buildings and outdoor environments, this right to light. Because, for instance, if you If you put solar panels on your house at home, you don't want your neighbor to erect a building or add a floor on top of his house that shades your solar panels after just 1 or 2 years, so that your investment is lost and your energy production. So this about solar access and the protection of this is really important. That will be, I think it will be very important in the near future to deal with this. Just shortly about Solar Decathlon here in Wuppertal, what I found is that you have used solar strategies in different ways. I'm not surprised. You used passive solar energy in different ways. You have used daylighting through windows, of course, and there are also examples of the indirect optical fibers to redirect the solar, the daylight. And you have used local renewable energy, so you have a lot of solar systems on your buildings. And you have also showed examples of local food production and the use of green areas. So you have really done a lot. To conclude, what I think about this is about solar strategies, is that how we plan a city, it really influences the possibilities for the energy production and for daylight access, and for many years ahead. So what we plan now, it will stand there for many years, since we don't change and destroy the buildings to just move around and make something new in a few years. So it's really important to plan well. There is a need for legal reform in many countries regarding solar access protection, and also improved planning approval processes, which is sometimes a hinder today, where we can have informed decisions. And there is a need of decision support tools and methods to assess solar potential, but also to consider the aesthetic values. And it's important to further strengthen teaching and dissemination for knowledge transfer, both at universities but also for professionals. And Solar Decathlon, I think, is an excellent way of doing this. And we need more developments on a city district level, as you have been working on, and the cooperation also between academia and practice. And I think you all have done a great effort to contribute to this development. So thank you for that.
Thank you. Right before this award ceremony, I had an interview with a third lecturer. I had a huge list of academic achievements, and I was like, well, what do you do with all of these? And he said, for example, you build your own house. Because he calls himself a builder with a degree. He's a certified carpenter with a PhD in engineering sciences at Ghent University, where he presently works as an associate professor of building science. Plus, he has worked on facades for Zaha Hadid, Norman Foster, and Renzo Piano. Please welcome with me on stage Professor Nathan van den Bos.
Thank you. So I'm Nathan, and I want to tell you a story. I want to tell you a personal story. So it was July 17th, and our team was excited. That evening, there was a competition award for sustainability and circularity. And that was the award we're going for. We went all in. We had a circular approach for the district, for the neighborhood, building, components, materials. It's really what we focused on. In Belgium, we won the Belgian Circularity Award, so we thought we've got this covered. Sustainability, we did the LCA analysis and we went the whole 9 yards. We calculated everything, transport of the students even, and the results we published in the most important scientific journal. We looked at carbon neutrality and we planted trees. We have a very small forest of 42 trees in Belgium to compensate for the carbon footprint, and we handed out more trees to reduce it even further. So this is really the competition we were going for. This was the one we want to win. We didn't even make top half. Somehow, we failed. We did something wrong. And when something goes wrong, you start thinking about it. If you have a lot of confidence, like when you have an exam, if you have a lot of confidence, you think, I got bad luck with the questions if you fail. If you succeed, if you're confident, you think, okay, I'm smart. If you're not confident and you have a good exam, you might think, well, I was a little bit lucky with the questions. If you fail, you think, I'm stupid. So we failed. So we were thinking what was going on. So we didn't know what to think. So at a certain point, I was talking to Louise, and she said, Nathan, you have to remember, every competition, every contest is also about communication. So I thought, it doesn't say solar marketing, your solar marketing competition. So it took me a while before it trickled in, but she was right. Of course she was right. You know? It's all about communication. As an architect, you know that, because if there is a design issue, there is no right solution. There is no one solution that everybody is looking for. As an engineer, and I was too long in engineering only, I was thinking, yeah, but I know the facts, I am right. And when you're too long in academia, you forget about something, and that is, in reality, nobody cares if you are right. You have to convince people. You may be so right, but if they are not on your page, it doesn't matter. Nobody likes a told you so. So you might have crunched all the numbers, but only if you can communicate it and get people on the same page, you might have an impact. So of course, communication is important. But I'm not a communication expert. I do know a little bit about teaching. And first rule in teaching is you have to know the stuff you're talking about. If you want to teach, and you're thinking about what you have to say, you're not thinking about how you have to say it. So before you can communicate, you have to know your stuff. So last few days, we went to visit all the houses. We got a lot of good presentations, but there's one student that really stood out. She was talking about the different systems, she was explaining everything quite well, but when we started asking questions, she brought her A game. She was like, okay, I know this, and everything we asked her, she responded right away. She was so happy that she knew the numbers, that she knew everything there was to tell about the project. She did her homework, she did everything, and she was happy to share that with us. So communication is important. You have to know your stuff, but the thing that really ties it together is a passion to bring it. And that student was so passionate about the work she did. So it's passion that allows you to crunch those numbers and work long hours to understand what your building is actually doing. It's also that passion that helps you to communicate and get your message across. And it's also that passion that gives you the purpose to build on these things and put your energy in there. So it's really nice to see that passion with all of you. So when we visit the houses, it's really nice to see that everybody is so enthusiastic about the project they did. And you should be proud of it. Of course, everybody had their own struggles. I don't know which struggles you had, but it's not easy to get here. But you made it. You had ambition, you put energy into it, and you're here. So at this point, I really want to say something about the Swedish team. They were up against a battle they could not win. But I do think that we have to appreciate that they showed heart. They hung in there, they tried. It's also really nice that other teams pitched in and tried to help them out. So I really hope that also they can leave the competition in a pride way and inspired by everything they saw. However, nevertheless, we lost. So, of course we lost. No team will win everything. It's impossible. Why didn't you win that contest? Why didn't you win the whole solar decathlon competition? Why didn't you become president? Got Nobel Prize. You know? It's meritocracy. If you go all in, everything is possible. And if you don't become president, well, either you lack talent, ambition, or work ethos. But of course, it doesn't work that way. Yeah? You have to go with what you have. You have to work with your context. You have to work with your faculty advisor. You have to work with your sponsors, with your budget. And you can only make the best you can in the circumstances that were given to you. But if you do so, well, do it with all your heart and try to get as much out of it as you can. Now, we didn't win, but the message trickled in and we tried to do better. So we really grilled our students to be better prepared for the next presentations. And we did win Engineering Construction Award, Smart House Award, and a few third places. But it didn't stop there. After the competition, a few contractors were inspired. And they said, well, that's really good concept. So we sold the concept, and if you now go online, you can order our design, and a social neighborhood has been built with our project. So we didn't win, but in the end, it had an impact. Now, 5 years ago, I was appointed tenure-track professor, and that means they give you a list. I had a list with 4 items. Publications, money, PhD, and research projects. And we got 5 years to get these numbers. If you have these numbers, you're in. If you don't reach them, you're out. A few months after that, I decided to participate in Solar Decathlon Europe. That's like a very stupid decision, you know. It didn't help in getting money, PhDs, publications, or research projects. However, it seemed like a lot of fun, you know. So I thought, let's do this. We did it. I'm very happy about that. And I can happily say that after 5 years, I did reach the targets. I got no problem. So I got my important meeting with the dean, with the board of professors, but nobody cared about the publications. The only thing they talked about is, well, we heard about that project. And apparently it inspired them as well to do other projects. Not in construction, but in other fields of engineering. So I'm really glad that even though it didn't help for my academic list, I really think it had a big impact. So the final message I want to give you is if you're passionate about something, go for it, and somehow it will pay off. Thank you.
Thank you. Now, obvious question. Anyone ready to win some awards? Yes! Woohoo! So, to announce the third place, please come back on stage. Professor Maria Wall.
Are you sure you want to know? I first want to say that it was a great experience to visit all the houses and meet all the dedicated teams. So you should all be proud of yourselves. But of course, not everyone can win. So the third prize is shared between 2 teams. Nice. So I will first announce one team. Good. Yeah, I will start with one team, and it's random, so it's not that one is better than the other one. And the first team to announce used a stepwise approach to study the overall building performance, the energy use and the indoor comfort, and the technical installations, with very good results. The jury appreciated how the different tools have been used for different purposes in an integrated way. And highlights were the adequate solutions for ventilation and PV for the design challenge, and the push notifications in the building energy management system, considering the user interaction, and the many interesting bio-based materials that have been adopted. Yeah. So the third prize, this one, the first third prize, or one of them, goes. I have to. Where is the envelope?
I thought you were going without me.
Ah,
There you go.
thank you. Ah. The first prize goes. The third prize goes to Team Roof Kit from Karlsruhe, Germany. Thank you. Congratulations.
Yeah, thank you very much for this prize. We had a lot of fun the 2 years working on our energy concept. And then we came here, saw a lot of really cool things at the other teams. And we didn't know, are we good at this? Can we do anything here? And now we were very grateful to have this third prize shared with another team. And I really want to know who's the other team.
Yeah, one more. So this also third-ranked team presented a solution for the urban challenge in their home city and successfully transposed that to the situation in Wuppertal. The energy concept comprises a range of passive strategies complemented with a well-designed active cooling system. The impact of different strategies is well quantified and had a clear impact on the overall building design. The most important feature that the jury appreciated was the user interface. By combining a BIM with a graphic display and tailored input to the user to reduce energy use, the team really hits a crucial aspect of the energy challenge we are facing as a society. Only by combining energy-efficient design and the user-centered approach, we can tackle this challenge. So, the envelope. Thank you. And the third prize goes to Team Azalea from Valencia. Congratulations.
It's so complicated. I mean, we are so grateful to have this international recognition to all the effort we have put in this project, all the ideas, all the negotiation with architectural team to put engineering in the middle to have the perfect integration with all the systems and make the house also look super nice. So thank you to everyone here, everyone in our hometown. We do this for the Cabanyal in Valencia, and we are really happy to be here.
Congratulations, Team Roofkit and Azalea for the third place. And now back on stage to announce the second place. Please welcome back on stage, Markus Lichtmes.
Hello again. I promise you no figures anymore. I will say something about the evaluation of the project. Sometimes, as we went through the houses, sometimes we asked stupid questions. But the stupid questions was the importance to know that you know what you do, to prove that everything what you made is right and you understand what you're doing. I promise you, in real life, we are much more friendlier than that. So, I will congratulate all the teams, and in my opinion, you all are winners. Your prize is the experience that you achieved on that journey. And, of course, there is the second prize. And the team got the second prize, presented a really excellent energy concept. The analysis of passive and active strategies were very well and detailed. The passive part of the energy concept lead to low energy demand, and the technical integrated fits the need of the system. The potential and also the limitations of the different active systems were well understood and combined in an intelligent way. On top of that, a building energy management system allows to study and operate the building, and the use of a forecast leads to improve the operation. Finally, a wide range of bio-based materials have been used in the building to reduce the carbon footprint. Congratulations. The second prize goes to, I need an envelope.
Second, okay, give me a second. There
Thank
go.
you. So I have to look. The second prize goes to Local Plus Aachen.
Oh my God. Actually, I don't know what to say. Yeah, that's incredible. That's really incredible. I think all our work and energy we put into that point we are now here, it wasn't, I can't talk anymore. So thank you very much, I think. Oh my God.
Thanks to the complete team. It was a really great challenge here for us. First of all, when we came here with a lot of water damage, and afterwards a lot of challenge from the electrical, from the complete part. And really, thanks to a team that we really managed. There were a lot of problems, and we really solved problem, and really, still we are not yet done.
Well done. Great.
Congratulations, Team Local Plus. And now, to announce the first place, please welcome back on stage Nathan Vandenbos.
So now, the moment you've all been waiting for. I already said everything I wanted to say, so I'm going to keep this short and sweet. The first prize, we selected a team that is really well-rounded. They showed an outstanding understanding of passive strategies, active strategies, heating, cooling, domestic hot water, and demand-side management. This team brings it all. They first optimized their passive strategies and really focused on indoor comfort. They developed an innovative engineering approach to balance heat gains, shading, daylight, and it can also be applied to other projects. They addressed the different operation of the systems throughout the seasons and showed clear understanding of how all these systems work. And that's what the Solar Decathlon is all about. Analyzing the energy balance, optimizing and integrating active and passive strategies, and bringing innovative ideas to the front with passion. So, the first prize.
There you go.
The first prize for the Construction and Engineering Award goes to Team Collab from Stuttgart. Push it over. Congratulations.
Okay. oh, I don't even know what to say, but thank you so much. We worked really hard on this project. We put a lot of effort and a lot of ideas into this, and we really wanted to push the boundary of innovative design, and it's so great that it worked. So thank you so much.
Roof kids, local plus Azalea, please come back on stage, have a group picture. And please make sure not to fall off the stage. Thank you very much. Don't get hurt, okay? We heard that there's some curiosity about the total ranking, or not the total ranking, but the ranking of this contest of engineering and construction. You curious about your points? Anyone? Okay. So, what the jurors did. So, 38 points to Lungs of the City, 41 to Deeply High, 74 to Team Aura, 75 to Team TDIS, 75 points as well to Extension for Sustainability, 81 points to Team Efton, 90 points to Team First Life, 92 to Team Level Up, 93 to Team Virtue, 94, you know it's getting more crowded, 94 to Team Sum. Hey. Yeah, just celebrate yourselves like every occasion. Yeah, go ahead. 101 points to Team Mimo. 103 to the teams Azalea and Roofkit. 106. 106 points to Local Plus. And 108 points to Team Collab. Congratulations to all of you. I'm sweating. Thank you, teams. Thank you, ladies and gentlemen, dear visitors. We'll have our next Out of Competition award in 41 minutes at 8 p.m. Thank you to the jury. Congratulations to the teams. See you at 8 p.m. Thank you. Surprise! Me again, welcome back! Great to see you all again. Plus, I observed that the amount of alcoholic beverages has increased within the last 30 minutes. Good job. Congratulations again. You enjoy it? No, he's shaking his head. No, I'm not enjoying it. Like, what glass is it? Like second, third, 18th? Second. Are you lying? Yeah, probably. I can see it. Enjoy, enjoy. Welcome to the second award of the day, which is the Indoor Air Quality Award, an out-of-competition award. And in order to have a better understanding of that award, I welcome the Technical Secretary of the Association for Air Conditioning and Ventilation in Buildings, Mr. Klaus Händel.
Thank you, Wilma. Thank you for being here this evening and awarding the special prize on indoor air quality. To say first, I'm more excited than you because it's my first time awarding such a special prize. So I will be even more excited than you who will get the prize. Ventilation. Ventilation is the basic element of the building. You must imagine we can, I would say, stay 30 days without food, 3 days without water, but only 3 minutes without air. So if the air balance is not given in the ventilation, we might have an issue. Ventilation in buildings is indispensable for removing CO2, our breathing. Today we can open all the doors, but not in every case. And please hear outside. You hear the motorway out and you will not be able to sleep here. Especially well-insulated buildings are tight and the automatically ventilation does not work. And ventilation heat losses in modern building are dominating more than 50% of our needs. It's not heating for transmission, it's not cooling for transmission, it's heating and cooling for ventilation, which are dominating. So having an eye on ventilation is key. Important steps are needed on the analysis and careful plannings. And also controls is a typical issue which is missed in some of the ventilation concepts. How to control a manual window airing? It's by feeling. You do many faults, and typically what we see is a window which is, let me say, open the whole day during night times and incredible heat losses and cold losses. I'm proud to present the awards. We have several criteria which have been circulated as well to you. Basic criteria for our ventilation award is the demand analysis. We have to analyze which people, humidity, fine dust, summer, winter loads are dominating our building, and as well the acoustic surrounding. Evaluation has been documented? Have you used modern plant technologies, building information modeling? Is it a fully digital planning? Is heat or moisture recovery implemented? Safe operation, also in frost protection areas? Demand controlled and implemented control technologies and links to building energy management systems? Demand side management links to the grid are important today as well, because our buildings are responsible for more than, in Germany, 30% of our loads. Can window airing? For sure, everybody should open the window. And can this be detected and prohibited? Then can the system react on that? Is filtration technology implemented? You see, fine dust might be an issue here. And are the materials sustainable and good implemented for maintenance and repairs? Have measurement carried out for indoor air quality and acoustics? These are our main criteria, and to be honest, each of the system we analyzed after a document pre-selection. It was 8 teams, did a good job, but I would say no one was perfect on that. Our issue was innovation, so we selected first time for innovations. And the second criteria was professional implementation, installation, and links to the other building systems. We found perfect ones doing one or the other, and ones who did a good job combining all them. So it was a difficult task. We visited 8 teams. Maybe you have seen me and the other persons of the jury. I would like to highlight them who was part of the jury. It was myself. I have the honor to stay here and speak to you. Then we have Claudia Cancia as well here, professor at the University of, and technical secretary as well for the Fachverband Gebäudeklima. Günter Merz, the managing director of Fachverband Gebäudeklima. Professor Müller from University of Aachen and Professor Stergaropoulos from University of Stuttgart. So we selected 8 ones, we visited, and it was a difficult task. We said, okay, we have to split half of them out, and for the rest 4, there will be 3 prizes, so we have to again find one who got the iron prize and nothing as well. So we found 4 teams. Sorry for all the others. To be honest, 8 of you did a perfect job implementing ventilation in buildings. We are sure you are mainly architects. Architects do not like so much speak about ventilation. They better speak about things you can see, nice shape and whatever. And ventilation mostly hidden, and mostly is hidden somewhere behind nice panels. But we will see. We look behind these panels, and we will see what you did behind. So, as said, our main aspects was innovation and professional integration. Now you will be excited who will get the prize. Third prize. The contribution of the third prize was particularly convincing due to high quality of the execution, the well thought out concept and the comprehensive operation strategy of the total energy systems. Both night cooling and actively cooling shading are used to improve the indoor climate. However, the implemented push-pull ventilation systems are not equipped with additional silencers, although there's a busy road outside. So we have to be a careful eye on a better design. The third place for this really good integration goes to Roof Kit from KIT in Karlsruhe. Herzlichen Glückwunsch, herzlichen Glückwunsch, herzlichen Glückwunsch, herzlichen Glückwunsch, 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 Glückwunsch.
Who would like to? There you go.
So you will get the prize.
Thank you very much. Yeah, we worked a lot on our ventilation system and also the passive strategies, not only active systems as our push-pull ventilation. And I want to thank Nico, our team member who did all the work on this stuff. Thank you, Nico. Yeah. Unfortunately, yeah.
And a special prize, it would perfect for you in Karlsruhe. It's VIP tickets for the TGR Congress next year in Berlin. Wonderful. 25. Everybody you can join and maybe learn a bit more about ventilation.
Thank you very much.
Thank you very much. You did a great job. The second place, team's contribution is characterized for a bold ventilation concept with an exhaust air stack that can be used for preheating supply air, adiabatic evaporative cooling integrated in the facade via trickle film application and downstream area. Through a well-thought multivariable control concept, the operation system under different operation conditions could explain in a comprehensive way. In the jury's opinion, possible restrictions on comfort and fire protection issues are still needing to be clarified. I would say this is the award for the best innovation. It goes to Team CoolLab from University of Stuttgart. Herzlichen Glückwunsch, gut. Herzlichen Glückwunsch, gut. Glückwunsch, 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 Glückwunsch. Ja. Bitte, den Pokal. Ich habe es fast vergessen. Nette Urkunde. Wer nimmt sie? Sie?
Ich nicht.
Okay, me again. We thank you so much for this award. I didn't even think that we had a chance because we don't have a really active cooling or ventilation system. So this is really cool to show our innovation and our innovative idea. Yeah, thank you so much.
And for you as well, the ticket for the TH Congress in Berlin. Everybody of you. Hopefully we'll see you. Now you will be excited for the first place. We have seen the best integration and the best innovation. So the first place must be the best one combining both of them. So we have a very good solution. The contribution of the first level is characterized with an excellent integration of ventilation system based on 3D building information planning. And the ventilation unit in the living space with a non-visible air distribution. All components from the heat and moisture recoveries to line silencers are well integrated into that hidden room. The air ducting was particularly compact design and partly equipped and developed with, I would say, components from a 3D printer. Possibly a design fault. But again, it's an innovation to print ductwork in a 3D printer. The first place is going to Team Level Up from Rosenheim. Herzlichen Glückwunsch. Glückwunsch. Hier, der Pokal, wer nimmt ihn? Wer hat das Projekt gemanagt?
We're very impressed about the prize. Actually, I have to tell it Markus, he planned it actually and built it, so yeah, we are very happy. Thank you.
Thank you very much. Really a great contribution. And again, sorry to say, we have 3 German teams, but I was excited. It was a surprise for me at the end as well. 3 tickets for the TGR Congress, VIP tickets, please. Hope to see you in Berlin. So again, thank you to all, and hopefully see you next time for the next award in ventilation. Thank you.
And as we announced, there's gonna be 2 out of competition awards. The first one was the Indoor Air Quality Award. Congratulations to the teams. And now we have the Solar Award. And in order to get a better understanding about that, please welcome the Vice Chair, Solar Heating and Cooling Program, Kerstin Krüger, on behalf of the Federal Ministry of Economic Affairs and Climate Action. Welcome.
Thank you. Dear Solar Decathlon heroes, the last prize today in line, the 3rd prize. Are you still excited about the solar prize? Maybe it's a sunset prize today? Who go for that? Our Solar Award is one of the 11 out of contest award, and we jointly award this together, ICES, International Solar Energy Society, and the collaboration program Solar Heating and Cooling. And just to introduce you to the both programs. No? We need the ICES presentation. Yeah. Who we are? First, we start with ICES, and I turn the stage to Klaus Feyen. He's the president of the International Solar Energy Society and director of the Institute of Thermal Engineering at the University of Kassel. Yeah.
Yeah, thank you very much, Kerstin. So I'm really delighted, and I'd like to be a student once again. There's such a good mood, so that's really it's funny. It makes us happy as well. Yeah, I briefly want to introduce ICES. I hope that several of you have heard about it, but just to give a repetition maybe. ICES is an NGO. This was founded almost 70 years ago, and we have members in more than 110 countries all over the world. And it's accredited at the United Nations as an NGO. And our mission, which is probably almost the same with the mission of several of you, it's 100% renewable energy for all, used wisely and efficiently. And what are we doing? So beside UN, we have a lot of cooperations with other organizations. One of the most important is this solar heating and cooling. And we do in the scientific area, we issue journals. You probably have heard about Solar Energy, which is a flagship journal for solar energy technology, and also our new Solar Energy Advances, which is an open access journal. We try to develop and spread information. So, for example, these infographics, which are easy to understand and directed to the grassroots people, not to scientists. But we have also webinars, and they may be interesting especially for you. There are monthly free webinars on solar topics of really high relevance, and you could register there, and then you get always the upcoming schedule and can join free of charge. And in the scientific sector, one of our main activities is just to hold conferences. And so we have a Solar World Congresses. These are every second year, and the next one will be next year in New Delhi in October. And we have the Eurosun conferences. They are in even years, and the next is in end of September in Kassel here in Germany. And this is the ICES and IEA, so International Conference on Solar Energy for Buildings and Industry. That is more or less that what you worked hard for as well. So it covers quite well the subject of the Solar Decathlon. And we discussed it, and we decided that the winners of the Solar Decathlon and the Solar Award, they will be invited to join the Eurosun conference in Kassel, and this is really a privilege, to give a talk in a scientific session to present their concepts and work. So usually all other scientists, even if they are extremely famous, they have to pass a rigorous review. But we have so much confidence in you and your quality of the presentation that we say the winners will get a talk, they get a slot in a session and can give a talk without review from our side. And we try to make another innovation, and that is, for the first time, we want to invite 100 students to take part free of charge in this Congress. Not all get an invited talk, but you can join and listen. And furthermore, you have a chance. We want to organize, get a locomotion at one of our local students who are enrolled in the master program in renewable energy. So maybe this is the start of very interesting international contacts, even on student level. So I could strongly recommend you to apply for this. The deadline is rather soon, so it's July 3rd. Eurosun2022.org, and there you find all the information. So what we also have at this Eurosun is a master course on solar energy. Perhaps you have heard already from your professor who has distributed the information. The master course works that way, that we have international groups of 2, and they follow one topic of the conference and report at the end in a seminar to the other students. And there are 3 credits also awarded for that, so you could use it even in your home program then for your study. And here the deadline is already next Sunday, so you have to be even faster. So 26th of June, we waited until the contest here so that you have a chance to take part as well. This is really, it's limited to 20 participants, and that's really a great experience. We have, ISIS has something like Young ISIS. So that's not me, as you think, but this is a network for young ISIS members, and that provides service and support and initiatives for young students or PhD students. And everybody's welcome. And we have even a young ISIS member on the board. That's Alina from Brazil, who's very active and is a very kind person there. And she's interested to get in contact with other students all over the world. And what does Young ISIS do at this Eurosun conference? So we have a so-called solar speed dating, where the young people can meet with established scientists and professionals on short roundtable discussions with 4 or 6 people and some experts, and then we change the group so you get in direct contact with experts you have only seen on the stage so far. There is a Young ISIS meeting, there's a Young ISIS party, of course, and it's a great conference, I can promise. We have more than 400 contributions from 50 countries, so it's really international, and several other things I do not want to mention now. So keep in mind, deadline July 3rd to get a free ticket as a student for this Congress. Yeah, and my final remark would be, don't miss to become a member in this great society, and then you could even form as member of Young ISIS maybe next time all the things, the inaugurations, the meetings, the parties we have there at the next Congress, and we would be happy to welcome you on that. Thank you.
Then I want to introduce SHC. It's already mentioned today, and first I would like to say, become a member in our SHC family as well. The SHC presentation? The other one?
You always want to present the award, so sorry.
Yeah. Maybe we skip that? to present SHC. Who knows about SHC? Maria Wall talk about 3 tasks we are busy with. Then yeah, okay. Then I want to talk about the solar heating and cooling technology collaboration program under the umbrella of the International Energy Society. It was one of the first programs that was founded in '77. And our mission is to work in collaboration together in this field. It's all about collaboration, and that is what you've got to know in your contest as well. It needs collaboration to design something great. In our program, there are 19 countries and 6 international organizations and the European Commission involved. What we do? We prepare high-quality technical information, and we work on the performance, we work on cost reduction, we work hard to push the solar thermal systems. We cooperate with stakeholders, we communicate about the potential, and we lead the research and development work. We have a lot of work in different tasks about solar energy in industrial, process heat, solar cooling, thermal storage, and thermal hot water, and all that stuff. What we want to do is sharing what we know. Klaus already mentioned the Eurosun. We invite you to join the conference. We have also webinars, free webinars. We have summer and fall schools. We have on-site trainings all over the world. We have national research days we organize. And maybe some of you know our report about the market on solar thermal energy, the Solar Heat Worldwide. It's now release of the new edition, 21. And who knows, who has got an idea how many square meters of solar collectors are installed in the world? Have you got an idea? No? What do you think? It's more than 1 million? Yes? More than 100 million? No? Only a few? Just I have to look at the number. I have to have it in my mind, but just to make sure. 746 million square meters we have in 21. That's according to 147.5 tons of CO2. That's what we are doing. Join us in our program. All the experts are involved to work together in the task. You find all the information about our solar heating and cooling research program under www.IEA-SHC.org. So, now it's time to find the last prizes. And Andreas, please come to the stage. That I first like to introduce our jury. That's Klaus Fein from ICES and me from SHC. But then we have Andreas Hebele, and he's the director of the SPF
Institute for Solar
Technology of the East Switzerland
University of Applied Science.
Of
Eastern
Applied
Switzerland.
Science.
Exactly.
Thank you for that. And he will give the laudation. The floor is yours.
So, thank you, Kerstin. Thank you, Klaus, for the introduction. Now, the Solar Award. First, I'd like to thank the organizers. Thank the organizers for the opportunity to award this solar prize on behalf of ICES and SHC. Our award, so the ICES SHC award, recognizes the most convincing technical integration, transferability, and significant CO2 reduction of solar energy use for the energy supply of the building or the urban neighborhood. So that's the idea of the prize. What did we look at? Is the concept in general, the overall concept, convincing? That was our question. Are we convinced about the concept? The functionality and the transferability. And so the three of us visited all of you. We informed us about the projects. What did we find? Now from a solar perspective, it has become here in this contest almost standard to have colored PV in the facade, have PVT and a heat pump for the heat supply for space heating and domestic hot water. We, of course, did find individual differences on how to cover the heat demand in winter, and especially on the different temperature levels. There are some special solutions out there. There are a number of special solutions with relation to solar energy, active solar energy use, on also the activities that SHC and ICES is working on. One is daylighting, for example. There is renovation with wall heating, prefabricated modules. Reuse of materials and components is what we found. Even really exciting things like also thermochromic materials change their color. Solar air heating with natural convection. All of these things. We were really extremely impressed now, not only about the technology, but by the team spirit that we saw. The teams helping each other. It's really not about winning only. It's an overall contest, and another thing, keeping the teams, student teams, motivated over 3 years, including a pandemic. How can you manage it? How can you imagine? And and then you finish at the site within 2 weeks. And what we also saw, really professional, very friendly and competent guides, the students who showed us their project. Also that is not, that comes not with every project. It's outstanding. So concluding is, for me, just the fact of you being here makes you all winners. We heard that already, but I think it is true. And now still, we had to choose a winner for the solar prize, but we couldn't make up our minds. So we ended up with 2 prizes. And I start with the second prize. It was a really convincing overall concept. The idea was closing a gap. That's the challenge. And the energy supply was with a colored PV facade plus PVT, plus an ice storage as a source for heat pump. And the heat distribution was with ceiling radiators with clay elements. Really great team spirit in that team as well. And incredible damage during the construction, but they made it. So who is it? Team Local Plus Aachen, Germany. Cool. Please come to the stage. So who takes the... I was talking mostly to you. Please.
Thank you very much for this third prize of this award. No, second.
Second.
I saw second. I thought the third prize. Yeah. So we worked really hard, and it's overwhelmed in combination with our second prize in the Engineering and Construction Award. So, yeah. Thank you really much.
Cool. Come on, we like to join you on the picture. And maybe you just stay here. We took a picture later. So the first prize of the Solar Awards, it's a renovation and addition of story challenge. Again, we were really impressed by the overall concept. The energy supply, again, colored PV, total facade. And I think this is really important. And to have acceptance, we need all area covered for energy supply. And acceptance in public is so important. So I like this idea of this colored PV, just to mention that. So energy supply, colored PV, plus PVT, plus solar thermal. The heat distribution, floor heating in that case, including phase change material, a cool power management system, and again, a professionally managed student team, bringing own PV power supply for the construction. So who is that? First prize goes to Virtue Eindhoven. Now we take all together.
Yes. Thank you very much. Indeed, we're very happy about this prize. We put definitely a lot of effort in our solar integration to make solar integration actually part of all the buildings so that we all love it instead of just copy-pasting solar panels on our facades. And of course, a big thanks to Chameleon Solar, Kevin especially for supporting our project big time. And yeah, thanks to the team that really put all the effort in this. Of course, out of award prize, but it means a lot to us. Thank you.
Good. So, that was it. The Solar Award. We hand over back to you.
Please stay on stage because we do have a special announcement. I know a few of you already kind of prepared because ICES and SHC invite all of you to have a glass of sparkling wine in the back of the event hall. So get all of the team members to the hall. Enjoy your drinks. Have a great night. See you tomorrow. Thank you.